Hello, welcome to Electronics Education. I'm Vincent Chang. So today I'm going to continue our learning around the Antonio inductance simulation circuit. Active filter based on inductor replacement. Part 2, bandpass filter. Active filter based on inductor replacement. Bandpass filter. This is the Antonio inductance simulation we studied in the previous lecture, which is composed of the 2 operational amplifiers and the 4 resistors 1, 3, 4, and R5, and then 1 capacitor C2. So the circuit covered by the red highlight is what we call the Antonio inductance simulation circuit, and then which is quite easy to remember. If you just follow 1, 2, 3, 4, 5, and then you put the odd number 1, 3, 5 in the numerator, and then 2 and 4 in the denominator. So then you choose the either 2 or 4 as a capacitor. Then you can this circuit can simulate an inductor, and the equivalent inductance is actually the 2, 1, 3, 5 divided by R4. And then, so when you face this circuit, so it's an inductorless filter, right? So it's the active RC filter. So we can just draw out the equivalent circuit of the original one. The equivalent circuit of the original one, you see, the inductance simulation circuit is now replaced by L on the top. We duplicate R and C. There's a buffer amplifier at the output. The buffer amplifier at the output. The buffer amplifier, what's the characteristic of the buffer amplifier? What's the characteristic? It's supposed to be a very high what? Input impedance, and then very low output resistance. So very high input resistance and very low output resistance. So now you are facing a what type of filter? What type of filter? What type of filter? Remember the analysis by inspection skill. You see the LC resonator at the output side, right? So LC resonator, so what's the frequency response? The bandpass. So it's going to be a bandpass, wide bandpass at low frequency. The inductor behaves like a short circuit attenuate, block the low frequency signal. At high frequency, the capacitor send out and then block the high frequency signal. So only for the medium frequency around the resonant frequency can reach the maximum transmission. So what's the center frequency? What's the maximum transmission frequency? But at this point, it's not 0 decibel, right? Because there's a buffer amplifier with the gain of K. So the maximum transmission gain will be 20 log times K. So the center frequency is actually what frequency? The resonant frequency of the LC resonator. So 1 over square root of RC. So now what is L? So L is just in front of you. So you need to plug in. So the omega 0 expression is a little bit complicated, a little bit ugly right now. All right. So this omega 0 is expressed by all the original component of the filter, active RC filter. So what about the transfer function? So it's a second order. So remember the second order transfer function, the bandpass, S squared as omega 0 over Q, omega 0 squared. And then put the first order term in the denominator, just copy to the top like this, right? And multiply by a K, the center frequency gain. And omega 0 is now, we know what's the omega 0, right? 1 over square root of LC. What about the omega 0 over Q? The inverse of what? Time constant. The inverse of, so you need to be very familiar with what I taught you in the previous lecture. So that's the time. Then you can apply, put all things together and move kind of fast. Have a very good integration with the skill, with the tool, and also with the concept. So this is the second order bandpass filter built around Antonio's inductance simulation circuit. All right? So this is the end of the lecture. In the next lecture video, we are going to talk about a very interesting circuit. It's the all-pass filter built around the Antonio inductance simulation circuit. So look forward to seeing you in the next lecture video. Thanks for watching.